the professor. Today we are presenting the vegetable flammable characteristic as a wildfire fuel. Our group number is 3. Next slide, please. So this is the table of content. We discuss about the project, the team, the progress, communication plan, different phases like requirement phase, design phase, development phase, as well as in the last we present the dashboard. Next slide, please. So this is our team. Jay Patel, who is a team lead. Then we have Rohan Patel, who work as a data analyst. Me, myself, Yash Ramani, work as a data analyst. And we have Jamin Adhikari, work as a developer. Next slide, please. So what is there is a kind of complex connection between plant and fire, and the three states of vegetation are decomposing, dead, and living. So why we doing this project? So basically, we want to make a system which will help forest authority to notify whenever there is a wildfire, so we can so they can prevent it. Next slide, please. This is the timeline of our project. Like when we create a project charter, then we gather requirements, then we clean and validate our data, then we perform some analysis and validate results. Next slide, please. And this is the remaining timeline where we close out the project. We hand over deliverables to clients. Next slide, please. So we start with the requirement phase. In requirement phase, what we do, we get the requirements, we create a project chart and project proposal, then we send those to client and get approval from the client. Then we collect the data for our project, and after collecting data, we again discuss the data with the client, discuss it with the client, and see if it can fit for our project or not. Next slide, please. So now we moving forward to design phase. Next slide, please. So basically, design phase is we divide design phase in 5 phases: identify data resources, data transformation, data pre-processing, hypothesis testing, and selecting modeling. If I talk about the identifying data resources, as I mentioned just a moment ago, that we find our data and we try to find a data that help us to achieve the best result. Then after getting the data, we do data transformation, data and data pre-processing, in which we clean the data, we remove null value, and trying to remove outlier as well for a better performance. Then in hypothesis testing, we try to find the which variable are responsible for wildfire, and how we can resist, how we can use other factors to resist wildfire. And the last is model selecting for predictive analysis. Next slide, please. So this is our data exploration part where we see the inside of the data. Next slide, please. These are the univariant and frequency distribution of different vegetation type and the different region, like northwest region, west region, southeast region, and so on. Next slide, please. This is the distribution for the soil texture, like how many data of each soil texture do we have, as well as the weight mass. Next slide, please. From now on, I like my colleague Jai to elaborate more. Thank you.
Then we started work on the pre-processing of the data. Like firstly, we started with the removing duplicates and null values from the data. So the left photo is for we have dropped all the null values to eliminate runtime error while analysis, and then we have checked that any column doesn't have any null values. Then we have removed the outliers and renamed the column for better understanding of each element. For example, the aspect is become a terrain aspect, and the texture become a soil texture, because only we can't know anything from only the texture. Then the C dot N ratio is became the carbon nitrogen ratio. Like that, we have changed the column names of all of them. Then we have handled the outliers, like this one is the box plot of the original data, and this one is the box plot of handled outliers. And the blue graph here shows the original data, and then after removing all the outliers or handling all the outliers, we can see that some data points are near to the mean values. So we have handled outliers for all of the variables, and then we move to the hypothesis testing, where we have done this because we can get to know that which are the elements we can use in our analysis, or which are the variable we can neglect it, or which are not useful in the analysis. So for that, we have firstly imported some libraries like Panda, NumPy, Matplotlib, Seaborn, sklearn, and many more. Then firstly, we have checked with the carbon analysis, like how much carbon content is in the each species. Then the moisture analysis, then the horizon thickness analysis, and then uh, pH soil pH analysis. So in the carbon analysis, we have ran one way ANOVA test, also for the moisture and for the horizon thickness. Then so these are the insights we get, that in the carbon content, the species species populous tremoloids that have a highest carbon content, and then the Betula papyrifera has the lowest carbon content. For the moisture, uh, the Pinus contrata have a very high in the moisture. Then then from this, we can see that Betula papyrifera and populous tremoloids have a equal amount, around equal amount of the horizon thickness. And any and then we can see that Picea glauca has the maximum amount of soil pH, like how much pH in the soil. So from this analysis, we can interpret so many things, like for firstly the carbon content differences. Species with the higher carbon content are likely to provide a more fuel to the wildfires than the other things. Like in this case, the Pinus contorta have showed the highest mean carbon content, and after that it's Picea glauca. So that two species have a higher carbon than any other, so that two species can generate more fire than any other. Than the moisture content, so lower moisture content means that there are lower fire risk. So the moisture content work as a work as a fire resistor. And and then the horizon thickness, like how thick is the wood, or wood is also important in the in the wildfire, because the thicker the wood is, it provide a more fuel to the wildfire. For example, this species have a higher mean thickness than any other, so it increase the wildfire risk. And the soil pH, last one is the soil pH. So soil pH can affect the vegetation density and composition. Betula papyrifera has the more soil pH than any other, so that might influence the wildfire. Now it's up to my colleague Jamin.
Thank you so much, Jay. So now we are going ahead to the development phase. Can you please move to the next slide? So here are some correlation metrics and the visualization plots, also the machine learning models that I'm going to present today. This is the code for the correlation matrix of your respective fuel characteristics, which is the organic horizon thickness, pre-horizon wet mass, and dry mass. So this is the all fuel characteristics of a vegetation. So it will represent that the pre-horizon wet mass has a multiple correlation, like with the wet and dry mass, and wet and dry mass for the post-horizon thickness. So which has most of the correlation. So here the interpretation of that confusion matrix, which says the organic horizon thickness is represent the depth of the organic layer in a soil. So in summary, the main flammable characteristics highlight in this heat map are organic horizon thickness, which means the more fuel, and the mass loss, which represent how much the fuel is consumed during the wildfire, and pre-burn moisture content that affect the ignition and burn intensity. So how intensive our fire is, which represent by the pre-burn moisture content, and we can compare with the after burn moisture content. So that is how we will get the intensity of fire. So same way, this is the characteristics of horizon thickness loss versus the dry horizon mass. So this thickness and mass loss, which has more fuel is consumed, where organic layer are thicker and intensifying the fire, as well as the temperature influences. So the higher mid-level temperature correlate with the greater fuel consumption, especially in vegetation with low moisture. So this is how this dry horizon mass loss and the dry horizon thickness loss represent the insight. So the low thickness loss is less than 1 centimeter. For small changes in horizon thickness are the several point where minimal dry mass loss. This indicates the lower combustion, possibly due to less available fuel or the moisture effect. Same with the higher thickness loss, which is greater than 1.5 centimeter. Points at this range generally show higher mass loss, suggesting the significant fuel consumption during the fire. So this is the insight for the particular scatter plot. Then we are move ahead for the correlation between the temperature and dry horizon mass. So it says the thermo mid-max, thermo low-max, and dry horizon mass loss. This chart represents uh, the temperature variability, which is sandy long soil retain the higher temperature raising flammability risk across the vegetation type on a level slope position. So the slope position and soil texture are lower slope with the sandy soil with higher mid-level temperature and increasing the potential of the fire spread as well. So that is for the particular correlation between the temperature and dry horizon mass loss. Then we'll move forward with the heat map of slope position. So as I have mentioned about the slope position and soil texture, so the lower slope with the sandy soil have the higher mid-level temperature, increasing the potential for the fire spread. So so the heat distribution across the slope position, so mid-layer temperature are generally higher on level slope position, suggesting the increasing fire risk due to the heat retention. And the soil texture role is to sandy loam soil, so consistently higher mid-level temperature, while clay loam and sand soil have lower temperature due to a better moisture retention. So the slope positions influence the upper slope with greater exposure to wind and lower temperature, while lower slope accumulate more heat, potentially increase the flammability. So this is the inside of this particular heat map, which has all the level, which is lower, middle, and upper soil positions. So these all are the soil positions. So this is the interpretation that I'll just speak. And this is the box plot of thermo mid-max vegetation type with the burn treatment. So this has an impact of burning treatment. So dry versus wet burn treatment, it reduces the mid-layer temperature and fuel consumption, especially in vegetation like Betula crepifera. And the species sensitivity is the populace has shows the higher flammability under the dry condition, while others shows the lower sensitivity. Another box plot is for dry horizon mass loss and vegetation type and the burn treatment. So this temperature reduction in a wet temperature with burn treatment, especially when the moisture is added, and effectively lower in a mid-layer temperature, reducing the flammability across the vegetations. So the variability among the vegetation type is the species like populus exhibit broad temperature range in a dry condition, indicating the higher flammability sensitivity. So most of the vegetations are more work as of more fuel in a dry condition as compared to the wet condition. And the last one, the visualization is the moisture treatment relationship, which is the moisture work as a buffer, so which increase the which lower the temperature in a vegetation to fight with the flammability, fight with the flames to reduce the wildfire. So now we are moving ahead for the AI modeling. So the very first model is uh, a normal classifier. So it is a random forest classifier. So we have just distribute the flammability levels, which is medium, low, medium, and high, and then we're going to predict the flammability as per the features of our data. So this is the code for the random forest. Here we have assigned similar on near 242 trees, decision trees, to make our random forest. So this graph shows that our dry horizon mass loss contains the most of the percentage in the decision making. So and as per the other three vegetation types play the simultaneous role in a prediction. Now we are moving ahead for the principal component analysis. So the clustering of vegetation based on their vegetation characteristics. So this graph represent the feature importance is dry horizon mass loss is the most significant factor in predicting the flammability, followed by the mid-layer temperature, while vegetation type has a minimal impact. So clustering for the risk assessment. So the clustering analysis group vegetation into a categorized by the flammability level, which help to identify and monitor to high risk of vegetations. So this is what the scatter plot represents. Then we are move ahead for the K-mean clustering. So here this K-mean clustering represent that. So this is the chart. So this flammability cluster of a vegetation type is vary from high flammability, which is 0, to low, which has a 3 cluster. So it based on the temperature and the moisture retention. So the management of implications is based on the higher flammability cluster. So it may need closer monitoring or control burn to mitigate the fire risk. So these all are the thermo mid max, thermo low max, and the pre-horizon moisture percentage. So it's all for the different vegetation characteristics. And so this is the elbow method to identify the number of K and another score analysis. So that's all from my side. Thank you. Now my friend Rohan will continue.
Thank you, Jamie. In the communication plan, we mentioned about our daily weekly status meeting. We did that. All are from the meeting 1 to meeting 8, and also mentioned our client meeting. What we did with the client bi-weekly. In this, we use the soil pH, latitude, longitude for the using the vegetation type. Here we define some the values for the temperature and moisture. Right? Then we put some condition for the lower value, lower risk, high risk, and the medium risk. After that, the put condition for 0 for the low, 0.5 for the medium, and 1 for the high. And in this, we use the volume map library for the map. So this is the map. Looks like. For a purpose by combining all temperature, moisture level, and vegetation type into a single heat map, it helps identify areas at higher risk for the wildfires. This enables better decision making for wildfire management, resources allocation, and preventative actions, especially by the targeting zones where conditions are more conducive for the fire outbreak. The code, and I made the table dashboard. Provide some interactive way to explore our result. And in conclusion, this study has to underscore the role of the vegetation in the wildfire risk, highlight specific types for more likely to serve as a fuel by analyzing the carbon, moisture content, soil pH, and other some variables. We have mapped vegetation types according to their flammability. And our predictive model and visualization provides a spatial awareness of the fire-prone areas, supporting for effective fire management strategies. Ultimately, our data-driven approach is aimed at enhancing prediction capability and aiding in informed decision making for wildlife prevention. Thank you.